Hello everyone! Today we're diving into the fascinating world of computer networks. Don't worry, it's not as complicated as it sounds. In this easy-peasy guide, we'll unravel the mysteries of networking. We'll learn how computers talk to each other. We'll explore the magic behind browsing the internet. Get ready for an exciting journey into the world of bits, bytes, and connections. Networking is like the invisible force that connects our digital lives. It's how we send emails, share photos, and play games online. Understanding the basics of networking can make you a more informed user. You'll be able to troubleshoot problems faster. You'll appreciate the technology that makes our connected world possible. So, buckle up and let's get started. In simple terms, computer networking is like building a digital neighborhood. Imagine each house as a computer or a device. Networking connects these houses with invisible roads. These roads allow devices to share information and resources. They can send messages, share files, and even play games together. Just like a real neighborhood, computer networks come in different sizes. Some are small, like your home network. Others are massive, like the internet, which connects billions of devices worldwide. Let's talk about two common types of networks: LANs and WANs. LAN, or local area network, is like your home or office network. It connects devices in a small area, like a single building. LANs are great for sharing files, printers, and internet access. On the other hand, WAN, or wide area network, is like a network that spans cities, countries, or even the entire globe. That's a WAN. The internet is the most famous example of a WAN. It connects countless smaller networks, allowing us to communicate and share information globally. Networking is the backbone of our digital lives. It's the invisible thread that connects us to the world, enabling a myriad of activities that we often take for granted. From the moment we wake up and check our emails, to the time we unwind with an online game or a streaming service, networking is at play. Here are just a few examples of how we use it every day, whether it's for work, entertainment, or staying connected with loved ones. When you hit send, your email zooms through a network of servers to reach its destination. This process happens in mere seconds, thanks to the intricate web of connections that make up the internet. Websites are stored on servers connected to the internet. These servers are powerful computers that store the data and content of websites, making them accessible to users around the globe. Networking lets you access and view them. Every time you type a web address into your browser, your request travels through a network to reach the server where the website is hosted. Multiplayer games rely on networks to connect players in real time, allowing them to interact and compete. These games require fast and reliable connections to ensure smooth gameplay and a seamless experience. Services like Netflix use networks to deliver movies and shows directly to your screen. Streaming services depend on high-speed internet connections to provide high-quality video content without buffering. Facebook, Instagram, and Twitter wouldn't exist without networks to connect users and share updates. Social media platforms rely on networking to allow users to post updates, share photos, and stay connected with friends and family. Networking is the silent hero behind countless online activities we enjoy daily. It's the foundation that supports our digital world, making it possible for us to communicate, entertain, and stay informed with just a few clicks. Let's meet the essential hardware devices that make networking possible. The traffic director of your network. It connects your home network to the internet and directs data to the correct devices. A network device that connects multiple devices within a network, allowing them to communicate directly. The translator between your network and the internet. It converts digital signals from your devices into signals that can travel over telephone lines or cable connections. These devices work together to ensure that data flows smoothly and securely across your network. Section 7. Finding your way online: IP addresses, DNS, and MAC addresses. Just like every house has an address, every device on a network has a unique identifier. This unique identifier is crucial for the device to communicate with other devices on the network. Without it, the device would be lost in the vast sea of the internet, unable to send or receive data. Let's learn about three important ones: IP address, DNS, and MAC address. Each of these plays a vital role in ensuring that our online interactions are smooth and efficient. IP address, or Internet Protocol address, is a numerical label assigned to each device connected to a network. This label is essential for routing information to the correct destination. Think of it as a mailing address for your device, ensuring that the data you send and receive goes to the right place. It's like a device's phone number on the internet. Just as you dial a phone number to reach a specific person, your device uses an IP address to connect with other devices. This unique number helps in identifying and locating devices in the vast network of the internet. DNS, or Domain Name System, is like the internet's phone book. It plays a crucial role in translating human-readable website names into IP addresses. Without DNS, we would have to remember complex numerical addresses for every website we want to visit. It translates human-readable website names like google.com, into IP addresses that computers understand. This translation process is seamless and happens in the background, making our browsing experience smooth and user-friendly. MAC address, or Media Access Control Address, is a unique hardware identifier assigned to every network card. Unlike IP addresses, which can change, a MAC address is permanent and is assigned by the manufacturer. It's like a device's fingerprint on a network. This unique identifier ensures that each device can be distinctly recognized on a local network, providing an additional layer of security and control. These addresses ensure that data reaches the correct destination and that devices can be identified on a network. By understanding IP addresses, DNS, and MAC addresses, we gain a clearer picture of how our devices communicate and interact in the digital world. This knowledge is fundamental for anyone looking to navigate the complexities of modern networking. Section 8. Speaking the same language network protocols. For computers to communicate effectively, they need to speak the same language. This is crucial because, without a common language, the data being sent from one computer might not be understood by another. Imagine trying to have a conversation with someone who speaks a completely different language. It would be nearly impossible to convey your message accurately. That's where network protocols come in. These protocols act as the universal translators in the world of computer networks, ensuring that all devices, regardless of their make or model, can understand each other. Protocols are sets of rules and standards that govern how data is transmitted over a network. They define everything from how data packets are structured to how they are addressed and routed through the network. Without these rules, the internet as we know it would not be able to function. Here are a few important ones. Each protocol serves a specific purpose and is designed to handle a particular type of data transmission. TCP/IP, or Transmission Control Protocol, Internet Protocol, is the fundamental protocol of the internet. It is responsible for breaking data into packets, addressing them, and ensuring they are delivered reliably to their destination. This protocol is the backbone of all internet communications. It breaks data into packets, addresses them, and ensures reliable delivery. Each packet travels independently across the network and is reassembled at the destination, ensuring that the data arrives intact and in the correct order. HTTP, or Hypertext Transfer Protocol, is used for accessing and transferring web pages and other content on the internet. Whenever you type a URL into your web browser, HTTP is the protocol that fetches the web page for you. FTP, or File Transfer Protocol, is a protocol for transferring files between computers on a network. It is commonly used for uploading files to a server or downloading files from a server. Protocols ensure that data is formatted, addressed, and transmitted correctly, allowing devices to understand each other. They are the unsung heroes of the digital world, working behind the scenes to make sure that our digital communications are seamless and efficient. Without these protocols, our modern connected world would simply not be possible. When you send data over a network, it's not sent in one big chunk. Instead, it's broken down into smaller units called data packets. Imagine each packet as an envelope containing a piece of the message. Each envelope has the sender's and receiver's addresses. The client-server model is a common way devices communicate on a network. A client, like your computer, requests information or services from a server, which stores and provides that information. For example, when you visit a website, your browser, the client, requests the website's files from the web server. The server sends the files in packets, and your browser assembles them to display the website. Section 10. The Internet. A network of networks. The Internet is often called a network of networks, but what does that actually mean? Imagine the Internet as a giant web. Each strand of the web represents a smaller network, like your home network, a business network, or a university network. These smaller networks connect to each other through special points called Internet Exchange Points, or IXPs. IXPs act like giant traffic circles, allowing data to flow between different networks. This interconnected structure is what makes the internet so powerful and resilient. If one part of the network goes down, data can often take alternative routes to reach its destination.